Hello, Jen. Good morning, everyone. Before we begin, I request everyone to kindly put their phones on silent. Thank you. A warm welcome to Acharya International Design Conference Day 3. The past 2 days have been nothing but an emergence of different visions, boundary pushing thoughts, and change making ideas in the dynamic world of design. All the speakers and presenters that we have come from diverse backgrounds. We've had presenters from architecture, product and industrial design, digital experience, and more, bringing a unique lens to our shared passion. They are here not just to inspire, but to provoke thought, spark collaboration, and ignite the kind of creativity that doesn't just follow trends but sets them. It's day three, the final day of the months that we have invested in this event. We are all a little emotional that maybe the celebration is going to end, but also relieved that all our hard work is successful and it's going all well. I urge our audience to treat this gathering not merely as a conference, but as a place where ideas are tested, paradigms are reimagined, and new alliances are forged. A big round of applause for day three of Acharya International Design Conference. For day three, as a keynote speaker, we have Dr. Sushant C.S. Dr. Sushant is the Dean of NIT Bangalore and a Principal Designer at the National Institute of Design in India. A 1998 graduate of NIT Ahmedabad in industrial design, he has worked extensively in furniture, interior, and bamboo-based design. He established the Design for Retail Experience Master's Program at NIT Bangalore and has held key academic and administrative roles. With over 25 years of expertise in bamboo applications, he leads NIT's Center for Bamboo Initiatives. A big round of applause for our keynote speaker, Dr. Sushant Singh. I request Dr. Sushant to kindly come on the podium. I also request our Vice Principal, Architect Jayalakshmi ma'am, to present with a token of appreciation. A big round of applause, audience. Thank you so much, sir, for being with us here. I give the mic over to you, or yes.
Okay, good morning, everyone. So, today I'll be talking the context of bamboo. Okay, so you're all very familiar with the material, the simple material called bamboo. Okay, but how much it can change our life and how much it can add to our clean environment. Bamboo can play a very big role. Okay, so you may be knowing bamboo is gaining lots of attention. Okay, all around the world, maybe some of you might have seen the Bangalore terminal too. Okay, so much of bamboo has been used. Okay, so everywhere, all over the world, bamboo is gaining a very big attention. Okay, so this time actually everybody talking about something about yeah. So everybody talking about sustainability, okay, green living, and we talk about the sustainability development goals. And bamboo is one of the material that can actually connect with many of these goals. Okay. So each one of these goals will be connect with bamboo. Each can be a topic for a PhD. It is like that. So, so much work is happening in the field of bamboo and people are connecting. It is for sustainable development. And one of our Professor Ashok Chatterjee at okay, some years back, not recently, he told being green is no longer going to be a choice. Okay, it is something increasingly becoming mandatory. You all know. Okay, it is happening. Okay, it's happening actually. And the way like moving forward, we need to be like more conscious about environment, green living materials, and what kind of like impact we are creating to the environment. So I think many of you like maybe have bamboo is one of the fastest growing material and it can be regenerated very easily. One of the most sustainable and eco-friendly. So you can see like many types of bamboo available the world in India and many sizes, many dimensions and many properties. Okay, you can see like a person standing there. Okay, you can see a person standing there. So you see the dimension of the bamboo. Okay, so huge bamboo. So there are like many things like one can see like the bamboo is not normative. Okay, so each species is a and it regenerate very fastly. That is why like it is sustainable. It's not that you cut the bamboo right, it's keep growing. Okay, so once you plant the bamboo, you can keep harvesting the bamboo like get flowered. Okay, it's like a life. Sometimes like the bamboo flower in 100 years. So imagine that you plant one bamboo, you keep growing like that every year, bamboo should. So it's like a 90 of period they are available in the 30 years. Okay, so not harming that now. That is why bamboo is getting such a big attention all over the world. And bamboo is like a fiber. Okay, so when you look at the bamboo, it's a very hard fiber, very very soft. So much application is there for this fiber. And like bamboo is something like you can harvest. Okay, you can cultivate any other crop. Cultivate, you harvest, you use it. And there is some problem also with that. Okay, when we talk like that, also thinking about bamboo, advantage of bamboo, there are lots of problems also. Okay, that is that in the beginning. Okay, but it can be so bamboo content also sugar. Okay, say glass. Okay, everybody knows a glass. Government also declared, okay, they changed the forest law in 2018 that they put back bamboo into glass. Okay, it's contained also sugar. So sugar attracts lots of insects. That is a harmful point for bamboo. So, but you can treat the bamboo, also treat it is right now. Okay, even if you have using bamboo furniture in my home for more than 25 years. Okay, sir also came to our office and we have lots of bamboo furniture we been using. Okay, so it is not just like a philosophy. It's also a lifestyle. Okay. So in our culture, okay, and if you look at Indian culture, or culture in Asia, Southeast Asia, bamboo is one of the primary. Okay, you go to Northeast, you go to Central India, you go to Kerala, you go to some part of Western Ghat region, Maharashtra, wherever you go. Okay, you will find that. You cannot miss bamboo anywhere. At least you will find a basket. Okay, so bamboo is everywhere. And we have a very deeply like a rooted system of working with now in India. You go anywhere, the previous line was northeast. Okay, here you can see this is central India. You can also cook in bamboo. There is a loom. Okay, baskets. Okay, very commonly seen bamboo product all around. And if you like, observe each of the baskets, there are nearly 450, 500 baskets are there in India. Okay, it's not just one basket. Okay, look at just here. So many kind of baskets. And each basket is designed for a purpose. Like you do a design process, you have a design thinking, connecting with the economics, connecting with form drawing, okay, form follows function. If you closely observe this basket, it follows everything. Okay, this have a function, It have a structure is designed for a particular usage. There's a closed field, open field. Okay, so it's a very well designed product. Okay, that is used in our tradition, in culture. Okay, but over a period of time, like now in our lifestyle, we don't see that plastics have any like opportunity like we can use it anywhere. We is just use it as a decorative item. So you can see variety of baskets. Okay, if anybody have traveled in Northeast, you would have seen some markets. Okay, so in places yeah, or Northeast, you see such kind of markets. But what I mean is now all these products are designed for lifestyle of past. Okay, the people, their lifestyle, agriculture, okay, they have something they need to transport, something they need to store, something they need to carry something. Okay, so all these products are designed for that. It's not relevant now. So our lifestyle. Okay, when you come to a new life, when you come to the city side or when you urban living, which is not possible to use unless something uses a decorative piece. Like people buy basket, put a lamp and hang it. Okay, so that is the maximum people do. So long back, Professor Anthony Ratchet is no more. Okay, some of you maybe remember this name, Professor Anthony Ratchet. He started like work in an okay with long. Long means like I can say precisely 1978, 1979. Okay, that long back. Okay, so he started all the activities of using that with India, like little more different approach as a designer. So he set up a center for bamboo research. Okay, where we do lots of research, product development, training programs, transfer of knowledge. Okay, we promote the material, promote new product pieces of bamboo. Then at bamboo also we have a drums. So we have a very big collection of products. People here we would like to interest you in bamboo. You can come, you can visit. We have a big collection of bamboo product and any bamboo. So what we do is we work with many species of animal. Like as I told, each species is different. You cannot use it may be same. Okay. But the character may be the property may be the fiber length, node length. Okay, there are lots of differences in species. So we have to identify and understand the experiment with the come up with lots of observation. Okay, so being bamboo like it is proposed as a new lifestyle material and people are started using. You see lots of Chinese product coming in the market. But you will not find much Indian products. Okay, because in India the perception is still backwards and craft material. Okay. We are not yet accepted. Okay. When we're talking about sustainability, we talk about green, we talk about everything, but we are not accepted value to our mark as our day-to-day life. And then we still work on plywood, wood, metal, plastic, alcohol, all things are there. So, NID what we are trying to do is this material, how we can demonstrate, okay, how we can demonstrate the number of products where we can use it in our day-to-day life. Process Kalidas deep learning collaborative. It's been seen, okay, like many students don't have participated in any workshop. So we try to promote, not like just being a lady, go outside and we have a workshop. We promote this material and we also try to incorporate other material. Like our major focus is the natural form of bamboo, but we also try how bamboo is being developed in industrial material, how it can connect that again to make a new form of products. So I'll just go through some products. Okay, first I'll go through. Okay, maybe if you want to ask anything in between, you can ask. So these are like the product developed for your daily life. Okay, so very simple product, dogs. Okay, how many of you use dogs? So many people at home use mouse. Okay, mostly metal. Okay, but the most nowadays you get a wooden one. Okay, mostly metal. Or now some places you see plastic handle with the steel. Okay. So bamboo is one of the best material. You can make it simply. Okay, no energy like problem like you produce steel with lots of energy. But bamboo nothing. Okay, every one of you can sitting here, you can make it long in 5 minutes. Okay, with that easy technology, we can go technology. Okay, even though it is a small handmade thing. Okay, so you can make it in 5 minutes. That is the time you require. Very little material. Such kind of product, you can keep it on dining table, kitchen, your office. It's such a beautiful product with little bit of bamboo, little bit of thinking baskets. Okay, so when I told about different species of bamboo, some species you see very big one, some are very small, some have a very our thickness is too much, some our thickness is only like a 2 3 mm. What should we do with them? When I talk to people when I was working, when I go to the field, people think you think bamboo is company. Okay, not do anything with that is only good for basket making. Okay, so then I told, okay, basket can be done. Been doing for many like centuries. Now can we do something new? So then we thought of thin bamboo without wastage. We split it, bend it, and make products. Okay, so you can like any number of product, any ranges of product, you can use it in dining table, dining table, kitchen, rivets. Okay, simple rivets. For dining table, keeping the hot utensils foldable. They can fold and keep it in a small box. Okay, so something again using like any context. You can use it in a dining table, you can use it like in a living room, or you can use it in a restaurant, in a resort, like hotel rooms. Okay, so any context you can use. Storage in kitchen, keeping onions and potatoes, so normally then we can keep it in the fridge. Okay, you can also put fruits, rice, all simple products. But you can connect everything like each one of them can connect with your lifestyle. You use it, you can use it, you can cook it. Okay. But you can see different way of making same products. Okay, different way like there's a last one on the top. Okay, you see that using a typical craft technique of Manipur. Okay, Manipur is one of the places you find that extremely like high skill man. So you see the surface of that, the top one, on the right. Okay, the small like all these pieces are tied with a small cane strips. Okay, it's a very highly skilled job. It's a single piece of cane. It's not that small pieces you are tying. Like one piece of cane, you just keep tying it. Okay. So we try to incorporate traditional method to keep some kind of authenticity of Indianness. So some of the students explore this kind of thing. Okay, you can see like this, you can just connect. So many of the youngsters you can connect with. You all use headphones, earphones, like steps. Okay, and we do with bamboo. Okay, remove plastics, reduce much. But you know, remove it, reduce. Okay, removal is not possible at this point of time. Okay, because the much like everywhere plastic is there. So removal is not possible, but reducing is possible. Ornaments. Okay, now I got an ornament made of wood. Why not man? Okay, so we also introduce ornamentals in NID's programs where bamboo ornaments are made and gifted to guests and participants and in our program. That is how we started. Then there was a demand for bamboo mission can be made more, train people to take it generally. Okay, so it's very simple. So we also do the product development, connecting with other countries. So we collaborate with workshop, we conduct this with Thailand. Okay, so this workshop why I put it here is this is done during the COVID time. Okay, so during 2020, when we were in the lockdown, sitting at home, this project was collaborated online. Okay, so after COVID, all these were prototypes. And that's another product that I had meeting. I myself had designed around 65 hammers in bamboo. Okay, all different species. Okay, so hammer is something like a very simple product which not like a very good market. You don't need a big technology to produce. You can scale up the numbers also. Before we have. Okay. So many of us travel so many cities. When travel, we need hangers to keep cold or something. So as body hangers, the corresponds to the garment, keeping it in a proper form. Okay, so we try to look at wherever possible, bamboo can be applied. Okay, so one of the core area that we work on furniture. Okay. So furniture again, like we look at the bamboo sector in India, we will make a huge one. Okay, we can take the bamboo very big diameter, huge furniture they make. Now the problem is most of these are made in Northeast. Okay, Assam or like Tripura or Manipur, Nagaland, all these places people make huge furniture. Now the problem is transportation. Okay, you are designers. Okay, so many of the furniture when you buy, it comes in a package. Okay, you open the package, you assemble it, the furniture is ready. Okay, so furniture market is changed, but bamboo furniture sector is not changed. It is same. Cane furniture also same. No, the huge thing come from northeast in Prague, and it cost a lot transportation. Okay, so in 2010 onwards, we started working on various models. Okay, so you can see that is the top corner. That is one of the first one we thought of making. How you make an outdoor thing. Okay, with the connectors, state structure. Okay, small state connector with one. So, and I had many years keep working. Okay, I can say that this furniture it is designed sometime in 2004 by Professor M.P. Ranjan. Okay, this is designed by me in 2009. So this is one of the first approach we thought of making a huge furniture. How you redesign it to make it knock down. Okay, so transportation cost will reduce. And then dismantle it, package, and transport. So this is like a maybe experiment in Nagaland. Okay, so you can see like same big bamboo, okay, same look and feel, but it can be dismantled and packaged. This is a full collection. Okay, so the full pot, single pot, double pot, everything we made dismantled. So made a one system that one system is applied in a another experiment we did. Okay, so again this furniture right now still bulky and very heavy. Can we make it lightweight? Okay, very lightweight. Okay. Two seater, three seater sofa. Okay, one housewife should be able to lift it and put it there. Right? Being or cleaning the home. Okay, now we need two people, three people, four people to pick a sofa and put it in the side. Okay, but can have a one housewife just in the sofa. Three seater, put it and clean up the place. So that was the focus. Okay, so we thought we'd make a minimum, bare minimum, structurally strong lightweight. So this was the experiment done on that. So came up with this So I thought that is a good challenge for us to get it done. So we thought of how can we standardize for furniture production. Okay, so that was challenge, but our challenge is not to make engineered panel. We want this natural form of panel. Okay, and standardize it. That challenge, like we started with using the solid bamboo. Okay, there is some species in India it is solid. Okay, so bamboo doesn't have core, solid bamboo. Okay, there are like I have studied around 5 species, which is solid. So fourth of them I have put it here. Olivary, Richie, Oxide, and Stickers. And each species you can see you will not find much follower in it, and especially the bottom side, up to around 10, 12 feet. Completely, some family you find complete, from bottom to top you find some. Okay. So you can see the diameter difference also. It comes. So that is assembly. So completely not be a table, office table. Okay. It can come in a package. Say, it's like a completely you can compete with the current kind of market, like what kind of style, wood, metal, or other material. You can completely compete. It's not for a craft material. It's not for a craft look. It's completely industrial. Okay. Okay. So this is a food collection. We did for a European market company. This is very simple. Okay, just connected based and bamboo rods. Is our own director office in India. Okay, we thought we also should promote using in our campus. So this recently we put an idea of the like director office. We started using bamboo furniture. So more places we are planning to use. So many visitors, more international visitors. So it's a one way like you can show this is possible. So we started again like introducing it to the market. Okay, so we developed the technology. Now who will do it? We cannot do it. We are academic people. Okay, so we started introducing to people, market. So another workshop, another one workshop. Okay, so another workshop in Thailand during the last World Bamboo Day. Okay, so people enjoy it. People they never touch bamboo, never work with bamboo. Okay, so this person now is sitting on top is the ex-CEO of Nike. Okay, so he heard about the workshop and he came. Okay, he told, I already work with bamboo. You teach me. And I you don't need to learn. You just do it. Okay, everything is there. Okay, so material is there, connectors is there, joinery, like we have demonstrated how to do it. And the second day they made the furniture. That easy. Okay, when I'm telling the people sitting here in India never made a furniture, they have made the furniture in 2 days. That is the kind of output. Very easy to adapt. Okay, so meanwhile, like while doing this, we adopted the bamboo knowledge to our curriculum also. So why not? Okay, why only like the we teach elements of color and this? Okay, why not? So we teach wood, metal, okay, all plastic, everything, but bamboo we never used to teach as a kind part of curriculum. People used to learn their own. I also never learned it from anything. I just by doing some experiment and over a period of 20, 25 years. Okay, so here we made it mandatory. Leaders in Indus furniture design everywhere, they have to work with them. And some students were just okay, this one furniture design students, but now we split this. Okay, we talked about bamboo, solid bamboo, but split also have got lots of potential. So NIT have done in early 2000s lots of furniture we split. Okay, Professor M.P. Ranjan have started the development. I have contributed, many people have contributed. Okay. So recently, like we introduced to our students. Okay, why don't you people work on campus space? So I can see some of the experiment. This is the steam bending. The student herself have done steam bending. She took a long piece of bamboo. She broke all the inner rods, made a tool, like close to one end, another end she connected to a pressure cooker. She made a around like a way of doing steam cooking. She steamed the bamboo, made the mold and made this and that. Another one of my student. You can see all bamboo sticks. Okay, you can make a beautiful furniture. Bicycle. Okay, there are a lot. to show, but just I reduce the slide because not much time. So some moment, weaving is also as I told, basket weaving is like another tradition you find everywhere in Southeast Asia. Okay, so weaving is also something we took it, that area we should not forget it. It's a traditional use of bamboo. This is something called Karnataka Kaya or Kerala. Okay, so weaving done by Tiger. Just last month, it got not last month, this May only, it got the GI tag. Okay, from government of India. So we have also used that material as a base for making many products. Some example, another example from different part of country like where we are introducing different clusters, folding lamps. Lamps are again a big problem. Right? Huge lamp. But again transportation cost a lot. So we introduced foldable lamps, basket for daily uses. Okay, so what NIT like believe design is a one thing. Okay, so you need to have an integrated approach of everything has to be there. Then only something can be successful. Okay, many times people think, okay, you introduce design, bamboo sector is like done. No. Bamboo sector major problem is the connectivity to the technology and markets. Okay, we still in India, you go any cluster they're making handmade. Okay. If they get a 100 piece order, they say no, because they cannot scale it up any of the products. And the technology also available, they cannot scale it up. Okay, so we always say, unless something like you connect with all the entire this chain, okay, it is always unfinished. So everywhere I told like when I talk to farmers or designers or I talk to entrepreneurs, I say, okay, you have to start from what bamboo is available to you, and finally, who are you going to deliver it as a product. In between, there are lots of things you have to take care. Okay, then only you can make a successful business out of it. Otherwise, it is not possible. So this is like something like a we always believe in that. So thank you very much. Like now maybe some of you as a student like there is a great possibility you can explore a lot. It's not like a not look at bamboo as a craft material, look at bamboo as a lifestyle material. Okay, that will change your complete perception of how you can look at bamboo.
Thank you so much, sir. That was indeed a beautiful presentation. It was so amazing to see so many items and products made out of bamboo, something that we have never imagined also. Moving on, let us commence with the presentations for the first half. We started with track 3, Sustainable Design for Social and Environmental Impact. So we have scheduled the presentations first
which will takes the heat and that means it will conduct through natural condition only. We are not using any fans or any other devices for cooling those devices. So it will increase the temperature of if you have about 50 or 60 ladies in this room, the temperature will rise by 1 degree Celsius. If it rises by 1 degree Celsius, it will if it is like that in the production of there are lots of productions happening in the real estate sectors to introduce to increase the growth of the plants. So for that, these agents are used. So for that only, if your 1 degree of temperature increases, this will make the plant to set off. So that's what the major thing is. The development of compact, lightweight, cost-effective, and aesthetical pleasing gadgets enhancing performance and extended operation life. It has made a major breakthrough in our whole lifetime. Okay? So further only smartphones for we are using other devices, smartphones, sensors, wearable devices, IoT models like thermal management and the engineering challenges we are facing through these major problems that are happening. So like you can see the motherboard is connected with the pin heatsink. So this is a pin design. So which is having some spaces in between there, which will conduct the heat that has emitted to the motherboards. The same thing if you take these LEDs are connected to the pin heatsink, which will absorb the heat from the LEDs. This also emit the heat outside there. So major of the production is happening at a faster rate since CAGR says that it has increased by 10.4%, and also it will increase by 10.4% by 2034. So the major problem for this usage of infinite instances, design selection for electronic devices because they are going towards compact devices. Not even we are having a small watches. The smart watches also have some LEDs inside. So it will also it doesn't make much of temperature, but also it will emit some temperature. So for that also we need to select the design for specific electronic devices, and it is heat sensitive and excessive heat causes failures and dimming incompatibilities, which will lead to the reliability factors, which will affect the reliability of the devices, which also leads to the lifespan, reduces the lifespan of the device. Driver power supply failures, which will make the device to set off or it will burst out. Like those poor quality will make those devices, and flickering, which leads to the poor quality of the device, less reliability as. So from that we can identify that from this literature reviews you can say they have this like Habib and al have identified that LCM heat sinks under natural conduction. So they have conducted ANOVA test and influencing parameters for those leads. And low power heat sinks with large conduction dimensions are identified are used by these researchers. And Because Sharif Verba, he has studied on the optimization of various teachings, different species like strike fin, pin fin, pole fin, or circular fin, and there are lots of fins we take. But strike fin, they have specifically taken strike fin and conducted generated genetic algorithm and predicted optimized values for parameters for a square pin fin. And bar coil, they are used just of regular fin under natural convection. So they research gaps fin thickness parameters vary depending upon material, fin space and fin height. So they perform analytical studies. So these questions arises when we from these researchers. So up to variations in fin height, number of fins and power inputs, which influence the parameters of aluminum fin hitchings, and optimal combination of design parameters, which yields to the maximum heat transfer for low electron devices. And how effective is Kaguchi method? Like this, they have used genetic algorithm, lots of algorithm they use, so parameters they have used. So we can use also Kaguchi method as a design of experiment method for identifying optimal thermal design parameters. And what is the quantitative improvement in heat transfer rate? These are the questions that arises. So from these questions, I have identified these are the major objectives to increase the heat transfer rate in low polarity devices. Minimum sizes. So this is a instrument which is being used for the data calculation. And I have used a multimeter to identify the connections between the to power the LED and also to measure the resistance and voltage values in between that. This is the experimental setup that I have used. Where the pin is taken, under that I have used an LED. And these measurements are measured using store imagery. So after that, to measure any device, we have to identify which one is the standard value for the which method is used. So I have taken three levels of system, which is pin height, number of pins and key inputs, which is given by the researchers. So level three says that 20 mm of pin height and 50 mm of pin height for level one, level one of 10 mm of pin height. And level one for number of pins, 16, 36 and 64 pins are used. For heat input of 520 watts has been used. So these are the three, that means 9 factors they are used. 3 cross 3, that means 9 factors they are used. From those 9 factors, they have identified 9 cases. So these 9 cases, varying the number of pins and pin height and heat input. For these cases, we have measured ANSYS. We have used ANSYS to measure the thermal performance. There's a numerical solution of those different things, which is having all the cases. Before I have shown all the 9 cases, those 9 cases has been listed out with the minimum temperature, maximum temperature, average temperature, which has been from all these cases, you can see that if I increase the number of pins, the maximum temperature increases. Also, minimum temperature increases up to 105. So, if we take a minimum pin now for 16, it gives a 75.4. So, even if I increase the number of pins, it makes the temperature increases. So, a small change in the pin height also makes a differences in the resistance. So from these, I have identified these response tables from the mixed method. So level 3 shows the fin height of
36.82. The number of fins of 35.77. Heat input of 41.92, which is a smaller but there are three reasonable factors: larger but normal matter, smaller matter. These three factors. So from these factors, smaller but factors will be because the temperature has to be lesser. For that, you can identify what is the number of fins, what is the number of night has been used. So this is the response plan for any frequency system. So heat input, number of fins and fin height. From this diagrams you can see the average surface temperature as a heat input of uh, from the degrees of freedom of 2 to 1, the total degrees of freedom. And from all this, the heat input has a significant difference between the fin height and number of fins. If the heat input is increased, the fin height also has to be increased, and the number of fins has to be increased. That's what outcome from this system. So this is a heat transfer coefficient rate for the different fin heights. And finally, this is the fin which has given the from this heat transfer coefficient rate, this is the fin which has given the minimum values. So this has been selected for the consideration of the result. So from all these things, for LEDs, we can connect any a smaller change in the design of the LED. We can reduce the temperature of 1 degree. We reduce the temperature of 1 degree Celsius. It will increase even the room temperature under a normal conditions. That's what the major outcome from this. The optimal geometry of pin of 20 pin height and 64 number of pins and 5 watts of input has been selected, which is identified as a best research. And the combined use of curvature and normal numeric analysis has given better results. And major factors that are contributing to the system is pin height and number of pins and the heat transfer. Acknowledgements to my knowledge. These are the references. Is any queries?
Thank you, sir. The questions will be asked later in the panel discussion which will be held. Thank you so much. A big round of applause to Mr. Devraj, please. Next, I would like to call upon Ms. Hemavati R to present her paper. Can we have the presentation, please? Not this presentation.
of this plant. So today you will dive into the complete idea about where exactly we can use and what is that major usage of this plant. So when this plant is traditionally used as well as modernly used. So when we say traditional usage of this plant is used to cure so many skin disorders as well as respiratory problems. Not only that, majorly headache, and also the digestive disorders can be cured with this plant. This plant has so many again parts of a plant like leaf, fruit, bark, everything. So everything can be used for different usages. And when it comes to sustainable potential, why again this is completely a modern use. This plant can be dyed. Here the part that I have taken from the plant is the leaf that I have taken. So I am not using the complete plant here, instead I am just using the leaf of the plant. So the leaf of the plant here. So why leaf is again we can achieve a different colors. So because when we say textiles and when we say modern usage and when we say fashion design, we need all about using different colors and colorful things. So that is why I have used the plant leaf instead of any other parts of the plant. And then moving on to, so that was all about the plant that I have used, and this is about the fabric that I have used. So anybody, any idea what is this Aries silk? So Aries silk again is a silk family. So why Aries silk? Aries silk is also called as ahimsa silk. So when we say sustainability, we should also think about not harming the insect. So Aries silk is all about ahimsa silk. It is also called as ahimsa silk or peace silk. So the production happens in a way that without harming the insect, which is insect, they allow the insect to come out by itself and then they manufacture the silk. That is why we call it as ahimsa silk. And then the process goes on again. It's completely hand woven, hand produced, and that is why I have used Aries silk, and it is completely, the process is completely eco-friendly. So that is the reason that I have used Aries silk. And then moving on to the production process. And before that, how to extract the dye. My students will definitely know how to extract the dye, but still, it's a complete thing. Like it's a easy thing. In an easy way, I can say how you make a tea decoction at home. It's the same process that you use. So you prepare the plant for the dye. So here the process that I have used is I have at room temperature I have dried the leaves. So it is not that we dry it under the sunlight. So when we dry the leaves under sunlight, we lose its color. So that is the reason I have dried it completely under the sun shade. So then it is made into a powder and dye extraction takes place without any addition chemicals. And we have extracted the dye. And then I have used a mordant also. Mordant here again alum. So why alum is because it is again a eco-friendly mordant. Okay. And then after the processing of dye extraction, it is a dyeing process. That is immersing the fabric into the dye solution. So again here there is a small variation that I have used. Is different variation in temperature and pH. So pH is all about whether it is alkaline pH or acidic pH. That is what I have used. And with varying temperature. I'll tell you why varying temperature and pH here again. And the process continues by making it with a constant temperature and the pH. So why this various pH and temperature? So various pH and temperature will lead us to achieve different shades in the color. That is the reason we have made the various pH and tested with various temperature range. And then this is what is the color that I have achieved. The actual color without any addition of moderate. Moderate is purely to change its color. Okay, and then moderate moving on to color shades. Color shades, it starts from brown, indigo, lemon yellow, goes on like dark shades of light pale, green, and brown. And then looking on to color fastness property. So when we dye any fabric with none, there will be a question like whether this fabric can withstand for sunlight, whether it can withstand for washing, whether it can withstand for rubbing. That is what will be a big question. That is the reason most of us will not tend to use natural dyes. So here, whatever is the moderate that I have used, it is a very good moderate. It gives a very, it gave a very good results with access to washing, light as well as the rubbing profit.
I would like to call architect Vanita Udata to present her paper. Can we have a presentation, please? The previous. Good morning, everyone. My topic is Sustainable Design for Social and Environmental Impact. My research question is how can sustainable design, rooted in traditional Indian philosophies like Panchabhutas, be effectively integrated into urban planning to enhance social and environmental results in fast urbanization? So, as you know, globally, urbanization is very rapidly growing, and this is happening due to high population growth as well as migration and changing lifestyle of people. And there's a huge demand for increasing lifestyle changes and consumption. The consumption also. So here sustainable design is a holistic approach to design that aims to minimize environmental impact while enhancing the social and economic well-being of communities. So it goes beyond using eco-friendly materials. Now here I have used a word as Panchabuddhas. So Panchabuddhas offer spiritual and ecological foundation for sustainability. So they remind us that humans are part of nature and that what we take from it has to be returned back to it. So we know Panchabuddhas uh, Prithvi, Agni, Vayu, Jal and space. So sustainable design concept is very expansive and covers not only initiatives in terms of design practices but includes sustainable materials, products, and the methods of environmentally conscious construction practices. As sustainable buildings consume less resources, its impact is also less and it makes them economically viable in the long term. So United Nations member states adopted in 2015 the Agenda for Sustainable Development. It provides a shared blueprint for peace and prosperity for people and the planet now and for the future. I have taken some case studies. So here I have taken example of the CII Soharaji Godrej Green Business Center, wherein they have adopted the sustainable principles of resource conservation, passive cooling strategies, energy efficiency facades, and maximizing natural light and air quality with traditional architectural elements like chali walls. Another example is solar, Tata Power solar rooftop installation at CCI Stadium, Mumbai, and how they are significantly reducing the carbon footprint. Another case study was Sweden's circular economy, wherein their approach is focusing on minimizing the ecological footprint and maximizing the resource use, minimizing waste, and aligning with the UN's 2030 Sustainable Development Goals. And Singapore's urban planning it will address land scarcity and density with green infrastructure, efficient public transport, and environmental policies, which is again demonstrating a holistic commitment and approach towards the society and the environment. So I have given some principles and approaches to sustainable design for social and environmental impact. So here we find architects like Laurie Baker, Rachika Krishna, even architect Neela Manjana, who have always used local available materials like the morning sir discussed about bamboo, which is a very sustainable material. So, and we have to follow those traditional methods of passive cooling through natural ventilation, water conservation, with recycling materials, using biodegradable materials. And all this is possible by collaboration with the government, NGOs, and communities, stakeholder and community engagement. So there are what we can find is there are various benefits, social benefits, environmental benefits, and economical benefits, which are the three pillars. So coming to the conclusion, here it's no sustainable design is not an option. It is a vital strategy for securing the future of both the people and the planet. By incorporating sustainability into planning, design, and everyday actions, we not only minimize the environmental impact, harm, but also create healthier, more equitable, and economically stable communities. So the benefits are multidimensional. Thank you. Good morning, all. Today I'll be presenting about the influence of the sacred geography on urban form. This is basically looking at the city as a response to its regional topography. This is an overview of the paper, which is looking at the geographical constraints as well as the built form, which is generated accordingly. Now, taking an instance of the city of Kumbakonam, which is also known as one of the sacred sites on the Kaveri River Delta, it is it is located. Yeah, it's located in Tamil Nadu, very close to Tanjore on the Kaveri River Delta, and it is known as the Kashi of South India. This is the regional setting, which talks about the Kaveri River Basin. So when we take a look at the Kaveri Basin, it divides into multiple tributaries on uh, on the southeastern side, which has split into multiple tributaries. The main tributary here is Arasalar along with Kaveri river itself, which shape in the city of Kumbakonam. Looking at the topography of the region, this shows the ridges and the valleys, and accordingly it shows how the lakes and the nalas or the connectors have been formed within it. As versus what you see on top is the actual tributaries that you have, and how the city is reflecting it as a topographical constraint. When you look at the sacred configuration, the main street lies right in the center, which is also running along with the city, along the rivers. And this is the main connector, which happens through the city itself, while the next set of roads are laid in perpendicular to the main spine. And you have the Kaveri and the Arasalar rivers on the north and the south of it, with the centers having a lot of these red spots in the center that is supposed to be the temples, along with the blue dots that you see are supposed to be the kulams or the lakes. When we did an analysis, we also figured out that the entire city follows the swastika mandala pattern of planning, which has the two rivers happening or edging the entire built form or the urban settlement being contained within itself, with the center having the temple right in the center, Shiva or Vishnu temple, along with the residential land use, which has the Brahmins, especially on the immediate periphery of the temple. It slowly descends across to the various other castes based on the social hierarchy system. And the eastern side is supposed to be having the palace area along with the old administrative buildings, along with the other columns which also happen to be on the northeast and southwest. When we take a look at this particular city, we see the multiple nuclei within the city, which are formed by the various temples and the columns, which form the main multi-centers within the city itself. And these centers have a series of, each temple has a set of Brahmins housing around it, along with certain various institutions like the chakrams or the mattams, etc., along with these agraharas, which are the residential components of it. And wherever you have the river, you also have the parikarais, which are basically letting you into the river itself or providing an access to the water. This is looking at the urban morphology of the entire city, which shows very clearly that in the center it's very contiguous with dense form, which is against what is seen in the eastern side, where you see the development quite sparse and plotted. So in the initial thing, the development or the footprint is happened in small fragments, which are all next to one another. So the build form is continuous and low rise, whereas what you see in the later stages is basically the block development that you see, which is all isolated units, or the entire footprint itself enlarges. And when you also look at the center, it's more built and along the street sides, which is engulfing a series of courtyards within it. So these connected courtyards happen to be the bigger open spaces that have evolved along the urban waters as urban voids. The same thing is seen over here along with land uses, which are concentrated towards the center in terms of commercial, that is along the main spine which connects it. Whereas the rest of the things, especially the institutional footprints, are seen more towards the river side on the north and the south, especially on the community side, on the top where you have the institutions aligned to it. Sorry, this I'm not able to showcase because of the color of the background. When you look at the nature of development and the build form that has evolved, we see that most of the center is occupied by the build, whereas towards the ends, you're having the sparse development, which is more of the encroachment that's happening. And when you take a look at the columns also, they have been spotted accordingly, where you have the writing on the right shows basically how these important pillars are being spanned across within the topography of the city, along with the connectors or the canals that are trying to stitch it up together. Now we also have the streets which have been mutating basically because of the transformations that have been happening along there. Earlier it used to be a continuous street, a street with continuous build form right in the front, which gives us access to the houses or the residential buildings. And all the rear spaces of these houses used to be the backyards which get connected to form in one consolidated open space. But now it's more of subdivision and amalgamation that's been happening, where you see these subdivision encroaching upon the rear spaces so that you do not have the kind of open space. Yeah, this particular transformation shows how the changes have been happening. In the first diagram, you see the contiguous built around along the streets with the inner consolidated courtyard, which is the urban void. In the second one, you see how the change is happening for the connectors or the nalas, which are being turned into red, that is the cement channels. And it also shows the densification of the urban block. And the last diagram shows how it has got over-densified and how the blue lines have got vanished from the surface. Now, this particular thing talks about the three scales of tanks that are there in the entire city of Magonan. The very first one is known as the Mahamakam tank, which is also known for the festival that happens, the Mahamakam festival that happens once in 12 years. And along with that, you have the next layer of the tank, which is more for the agricultural purpose, which is just for irrigation. And the scale also varies accordingly. And the third one is for the neighborhood scale, which is catering to the residential purposes. So, as a conclusion, I would like to say that, as against the presentation that I had yesterday, which is showing the evolution of the city itself, how the urbanization has been encroaching upon the current urbanization trends, and how the changes have happened trying to engulf the entire water network. Here, most of it had been very compatible or complacent when compared to what is in the case of Bangalore. And if we are going ahead with this kind of a sustainable development where we are depending on the water for culture or any of the other purposes that it serves, then it's going to be a better thing when compared to losing it out in case of the urban land, land. Thank you. Thank you so much, ma'am. I now request Miss Brunda G.S. Miss Brunda, do we have Miss Brunda with you? Moving on, maybe Dr. Soumya D. Dr. Soumya. Alright, I think we could move ahead with Dr. Hemalata Romani as the students would maybe our co-authors would be presenting the paper. So can we have a big round of applause for Dr. Hemalata Romani and her co-authors?
Good morning, everyone. Today I am presenting on Navalgam Chamkanas, a traditional handmade craft of Karnataka, also known as Navalgam Daris. This was prepared by Dr. Himlada Dodmani and Spurti Nalikapa. Here's a quick look at what I'll be covering today. Let's begin with the introduction. Navalgam, located in Karnataka, is renowned for its traditional handwoven drugs known as chamkanas. These are not just functional textiles, they hold deep cultural significance and are known for their durability and unique geometric and motif-based designs. Most importantly, this weaving tradition is exclusively carried out by women, passed down to generations. Navalgam Chamkana received its GI tag in 2011, highlighting its cultural importance. The historic and cultural significance. The roots of this craft back to the Adil Shahi period. This vibrant weaves featuring animals, birds, and symmetric patterns are often used in rituals and weddings. They are proud symbols of Karnataka's culture and architectural heritage, and also provide livelihood to rural women, contributing to local employment. The materials used here are the horizontal frame loom, yarns, a spinning wheel, beaters, combs, shuttles, and scissors. This technique involves preparing raw materials, setting up the loom, weaving the base, adding intricate details, and finally inspection and packaging. Each step is handled with great care and precision. The challenges and resolution efforts facing by the artisans in present generations are declining demand due to machine-made alternatives. Fewer weavers are younger generation move to other jobs and limited income for artisans. There's also no public awareness about the value of these drugs. However, preservation efforts include the GI tag, government subsidies, NGO support, and craft exhibition that help promote awareness and research by the market. The methodologies are followed by a mixed method approach, combining historical research with fieldwork and interviews. This helps us capture not just the tangible aspects of the craft, like the process, but also the intangible ones such as traditional, social impact, and the emotional values held by the artisans. These are some of our designs. The first one is overlapping layer, symmetric peacock motif jacket, squared patchwork jacket, symmetric carpet and fringes jacket. The last one is red and yellow banner jacket. The SWOT analysis includes its handcrafted, eco-friendly, and long-lasting. Rising demand for homemade products and interactions into modern fashion and e-commerce. It's labor expensive and less known outside niche markets. Competition from cheaper machine-made products, urbanization, and the risk of skill loss as older artisans retire. I would like to conclude by saying that Nobel-Contaris represent a beautiful blend of culture, heritage, and craftsmanship. Their survival depends on collaborative efforts across design, education, marketing, and policy, with the right support and innovation. This craft can remain relevant and inspire generations to come. Thank you.
Thank you so much. To present next, I would like to invite Mr. Basavraj Sankor. A big round of applause to Mr. Basavraj sir, please. Can we have his presentation?
Thank you. Good morning, everyone. So, our research topic is finding the sustainable product attributes, design attributes for the product when we have the consumption. Myself, plus is a PhD candidate. The others, just I'm giving a university. And Professor Acharya was joined. He's my mentor, and he's the co-author for this. So, everybody knows that what is sustainable development and how do we bring sustainability into our daily day-to-day design. So, as per the different UN Sabha Question 1983, they have made that sustainable development is a development that meets the needs of the present generation without compromising the ability of the future generations to meet their needs. So, for this, they have developed around 17 sustainable goals. Goal number 9 and 12 are related to the industry, where the designs, the industry development, industry infrastructure, the responsible consumption and production to happen. So, while designing the product, designer should aim for goal number 12, where we have to design responsibility, consume responsibility, and then for the production. So for any product to develop, so there are some transformation in the industrial production processes. They have some inputs, they have some outputs. So inputs is energy, material, workforce, capital, and outputs what we get is the goods or service. But along with that, we do get waste and the emissions also. So how these waste and emissions have an impact on the environment? That is represented by the IPAT equation, where I is the impact, environmental impact is equal to population into appliance into technology. So, as a designer, we have control only under technology in this situation. We take a closer look. So, as a product designer or industrial designer, the only the impact or the attribute you can control is the technology. And how do we control that? By methods and processes used to produce and consume the resources. So that is how we are, as a product designer, we are able to control those. And these waste and emissions, you know, can be well understood and defined as a regular application. So that is called as a butterfly diagram. Where in this we have the biosphere and other technology. If you take a look at the biosphere, so every input and output, there is no kind of landfill happen or the waste is taken. Everything is moving into the soil. It comes from the soil, it goes into the soil. There is no landfill as such. But when you do for the atmosphere, we have the products, we have the mining activities, we take the rare earth metals from the earth and we do consume those materials to make our products. And during the products, we do the landfills. Because when the product life is over, we are going to throw it on the industries. And that becomes as a landfill for the life. So, what does it say? When the products becoming, reusable or redistributable, when the product become reproducible, remanufacturable, when the product is able to recyclable, then there is a lesser emissions, lesser waste, or this waste can be delayed for a period of time. But still, when this waste becomes input to the next product, that is where the circular economy and circular things will come into the picture in the sustainable development. So now, what is sustainable product design? There is a lot of interest in terms of the researchers that how the product should be designed sustainably. Or how do you call the design sustainable? And what are the measures we take to make the design sustainable? What are the attributes we take to make the design sustainable? So, and addressing the sustainability after the product is produced, after the product is made, then we don't have any control once the design is released by the designer. So before releasing the designer should think about sustainability, blend the sustainability aspects into the product design before it gets released. Because as per the research, 80% of the sustainability impact is determined at the conception stage. So it is designer thing that we must understand the sustainability aspects of the product when we design the products at the conception stage. Because 80% is controlled at the design stage. The rest 20% is controlled by the operations. Because the operation works as per the design inputs. So, so the conceptual stage is the stage where the product functionality and sustainability outcomes are produced and determined. And for these outcomes, these decisions made early in the product design cycle have an impact on sustainability. We can conserve more resources of the rare materials, and also we can have the economic product design cycle. So, so sustainability there are three pillars: social, economic, and environment. And the environmental impacts we must quantify it by the IPAC equation. The economic impact is the how much cost is saved for per product, how much cost is benefited, how much cost is paid less by the consumer during the product production. So, for example, if you are designing the water heater and the water heater is consuming electricity every day. So the economic aspects of the water heater is how much less energy is consumed, but still you get the water. So that's the economic aspect. And social aspect is the product reaching to the all aspects of the social, and it is reaching to the mass. Is it the product is successful in the market? So, there are some elements and the descriptions about these social sustainability, economic sustainability, and economic sustainability. There are some research went into the green design, eco design, then for sustainability and sustainability itself. So, design for sustainability and sustainability, these are two things. Sustainability is just it is a direction which gives us to make the sustainable design. So, and lately the research shows that 5 to 10% consumers are willing to pay more when you label that the product is environmental friendly. They are eco label. So they say that they need to pay more if the product is environmental friendly, and also if you choose to select the products which is the environmental friendly product versus lesser environmental friendly product, then consumers are preparing environmental friendly products. But there's a lot of awareness is happening around the product design, a lot of awareness is happening to the product, to the sustainability aspects of the product. And these are so what exactly SPD, I mean sustainable product design means. I will give an everyday example. It is a toothbrush. Right? So it requires daily, some changes monthly, some changes weekly, some changes in after 3 months, some you will remind to change. So, so this is it has two components. One is a stem, another is a brush. Right? So how do you design it sustainably? How do you say it's sustainable or not? Nowadays, if we go to any hotels, we see that the stem is made from the wood, and the plastic presses are, kind of, engraved into the wood, so it becomes to a illusion. This system is not that illusion. They did a lot of research and implemented that to save the plastic waste on the planet. So if you design like this, only the brush is separated from the stem. So you just change the brush and the stem will remain same. The stem can be there for 10 years. So instead of every 3 months you change the brush or every month you are changing the brush, the plastic waste is going there. So if you separate the brush from the stem and do 10 Newton force, you like to brush your teeth and that brush interface with the stem is made, a reliable interface, then you can save the stem material throughout the, at least for 10 years, consistently. So the other examples, is the phones, hands in your phone. So there are some research happening. The Dyson phone and the Palms pen. So comparing these, which product is sustainable is really difficult challenge unless and until you get the real data from the mining to the end of the product. I will say as cradle to grave, cradle to pedal, cradle to gauge, combinations. You have to design the system what because you are taking sustainable aspects of the product. So these can say that the flow setting and high setting, how much power is consumed, which material is used. Again, the material system is going to change, the data is going to change every day. So every year they will update, the life cycle analysis to know whether the products are really sustainable or not. The product sustainable today may not be sustainable tomorrow. The product which is not sustainable today may become sustainable tomorrow because of the innovations happening around the world. So another example is phone. This is the Europe's most sustainable phone, which got a gold award in sustainability. But still, it has 40 kilogram per carbon equivalent it is producing. Just imagine how much carbon equivalent our phones are producing. So, which is got an award of a gold, but still it has 40 kilograms of carbon equivalent it is producing to make this phone. Why they call it sustainable? Because the outer case everything body, the pace of the technology in the mobile phones, right? Every 6 months the new technology comes, 4G, 5G, 3G, like that. Everything, the chips are changing. They designed in such a way that the outer case, the body remains same. It's replaceable, reusable, the modular interfaces. You can just replace those with the standardization to the design process. So now this is the solar car. So we really don't know if it's sustainable or not. Being solar is not sustainable, right? Because to make solar, you have to send a lot of lorries to dig the earth, a lot of cranes to dig the earth. Those lorries and the cranes are not sustainable because they're emitting a lot of emissions to the environment. So we really don't know whether this is sustainable or not. So what to do? To know it is sustainable or not, we have to do the life cycle analysis of the product, from to get the data, how this car is manufactured, where the materials is coming, how it is procured, from how long it is procured, and what is the carbon emissions to get this product car. So doing all this, we have to do the life cycle analysis and using the softwares like SEMA Pro, Gabi, OpenLC, then we can label whether this is a friendly product or not. So, from the research studies, there are a lot of research is happening, and the researchers coming with the design. When we start designing at the conceptual stage, what are all things we have to consider in mind? Maybe industrial designer, maybe product designer. What are all things he has to consider during the design so that as the design progresses, the design becomes sustainable. If the design becomes sustainable, the production operations also become sustainable. Because the research stage, 80% of the sustainability are defined at the conceptual stage. If you are able to define those at the conceptual stage, then definitely your design and the operations will become sustainable in the future for that particular product. So, from the literature studies, there are a lot of tools and techniques have been done. And again, the economic, environmental, and social. Some of those able to provide all pillars. There is some are providing to the economic area. So we have these tools assess the design. Once the design is made, there is a gap. Once the design is made, they access the design whether this design what is made is sustainable or not. But while designing, if there any tools, techniques, or while designing the product at the conceptual stage itself, do you have anything can the designer mind able to control that whatever design I'm making today will become sustainable tomorrow. So that's the gap. And that gap is, considered this, this is best example because when someone comes to tell a beginner designer, say 2 years experience or 5 years experience guy, tell them that design system approach. The 2 year guy, the beginner designer doesn't even come to know the word system, right? And suppose if you design something, how do you know the design product is sustainable or not? So what should be done to these beginner designers so that the design becomes sustainable and the operations also become sustainable, so that we can conserve more resources from the planet Earth, so the Earth becomes green. So what should we do? All this is done by the attribute because when you start any concept of the product, the knowledge of that product is very very given during the concept stage. It gets stronger and stronger once the development starts. But as the industry was a time limits also. For the concept design, we hardly get month or 2 months of time. So in just 2 months or 2 months of time, we have to get the concept, get the technical feasibility of the moving forward. So while doing this, the knowledge of the product is very very given. But as soon as product gets in shape, product gets some kind of idea, then you know the proof of the product. At this stage, how the design should be, how the system will be. Because at this stage itself, we run to the full product. And how do we design and the top of how do he make the design system itself. So for that, it is evident now to know those attributes which are contributing to the sustainable design, or which are contributing to the sustainability of the product. And those attributes we are identified as sustainable product design attributes, called as SPDA. So these SPDA, if the designer knows, or these SPDAs are made available to the believing designer, he can think about sustainability while designing the product at a conceptual stage. Now, contribution of this paper is that we have the traditional design method that is called the product design matrix. We label it as a PDM. From the PDM, we are developing the sustainable product SPDs, sustainable product design attributes. And these SPDs are expected to help the believing designers to design sustainable. Our aim of this paper is very, very simple that the beginner designer should blend the sustainable aspects into his design that we are taking successful. So this is the main contribution for us. The designer should be able to design sustainable. So how do we develop the PDM? We are listing PDM. PDM is nothing but your traditional design methods. From the PDM, you are developing the identifying the SPDMs. SPDMs is sustainable product design methods. Matrix. And from the SPDMs, you are identifying we are deriving the SPDs, which is called. And from each SPDs are identified environmental, economic, and social. So this is the methodology for it. We have the certain pillars, environmental, economic, and social. We are listing down the PDM product development matrix. These PDMs are nothing but your traditional design methods. And from the PDM, we are identifying sustainable product matrix, which these are the attributes which if you control or increase decrease, your sustainability will increase and decrease. And from here you are deriving the SPDs. These are more or less the checklist guidelines for designers to be able to work towards these guidelines and definitely these design will become sustainable. Right? So our this is right now related to environmental and social. So identifying peaks and attributes will help control the design, and that the control is with the designer hand. Right? So, if you again the environmental pillar, we have straight down in product design matrix. Design para, design for X, concept design. These are all traditional design matrices. So, to make sustainability, how which are the contributes, which are the factors, which are the attributes of contributing to make the design sustainable. These are listed as sustainable product design matrix, SPDMs. You take the concept, material, component geometry, packaging design, distribution, use operational. None of what they use of distribution design. Right? We have to design for distribution. We have to design for operation. We have to design for enterprise. It's all designers. And design for you even do design for reuse, design for even design for repair, design for repurpose, design for recycle. Everybody knows what's wrong in what's new in. We have identified some of the design for reuse, design for repurpose guidelines and checklist. If you incorporate these into this conceptual design, then your design will become sustainable. Like that, we have mentioned all the again they are not. For the social, we come across the health and safety and documenting open architecture product reach quality as our major product metrics. And from there, we are developing the SPDX, Sustainable Products and Metrics, considering hazards, governance, product safety, size, handling, installation, aspects, inability, product assessment, design for disability. For open architectures, is nothing but a phone, which is open architecture product. Anybody can open the phone, get the new technology standardized nodes into it, and use it. You go for the store or the service centers to get your phone repaired. So it's kind of that self-repair or the upgrade. The product should be reached competitive price should happen to the product. The quality of life also should improve using that. So these are become the social pillars of the system. So now, I'll give you one example here. How these SPDMs are developed. Again, the SPDMs. So SPDM is material. Now the attribute which is contributing to sustainability. So in material, the quantity and variety plays important role to the sustainability. Reusability, recyclability and reusability play in the secondary consumables. Long lasting, scrap and waste, compliance, renewable biogas. So the guidelines again we have mentioned, mathematical strategy, similar development of product activity, source of dematerialization principles, when you are designing new products, lightweight, this should apply when you are designing for the product design, producing the thickness, the performance, minimize composites, digitize the demo products. So these are all things we develop. And we are making a case study that how these SPDAs are quantified and how they, by looking at the PhD, the individual designer can understand easily that how these factors are contributing back the system, how these factors are contributing back the product sustainability, product environmental impact, product social impact. So like this, we develop a compound geometry. So there are lot of research has been done. We can design for art. Ours, we put the product on in terms of time spent into the user. The user is using time. A lot of research has been done, and there is a lot of if the design allows you to use the recycling of the product like this, then you are able to reuse or redistribute the product, the product like this. You are able to reutilize the product, the product like this. You are able to repackage the product, the product like this. Means that customers are not, use water for 2 years and throw it away. Which means the then use. To make use of the longer, what the design wants, it should be able to design for recycling. Means that you have to use the recycling materials to the design space. Then only we are able to recycle. So like that, lot of aspects we have seen. How the usage of time when you are replacing or upgrading the product when it comes to sustainability. performance index. So we are upgrading the product. At the end of the life, you look at a blue product curve at the end of the life. That is how the product should behave. But when you consider the system aspects of the product is becoming like cycle 1, cycle 2, cycle I. You can upgrade to the end number of things. But to do that, your design should accommodate modularity principles. So now that you identified the approach is modularity, then you can able to control these cycles. You know that with the research from the university that if you reevaluate product to launch and extension phase decline, the product is remain in the market for longer time. The product is consumed by the user for a longer time. It's a long-lasting product. You don't know again go get new materials and make it, right? The same product is extending its life. So in this way, we are consuming the lesser resources, and consuming the lesser materials from the earth to make the products. It become long lasting. So that is one of the product attribute we identify. So we know that linear economic recycling, economy, and circular. The sustainability shows the circular that there should be minimal waste. Instead of wasting full product, it should be minimum waste. You should be able to recycle it, you should be able to repurpose it, you should be able to even use it. And to do all this, the design should allow. The design should allow even the design should allow recycling, the design should allow design for assembly, the design should allow design for disassembly. These things should allow, and this is controlled by design. And this is one of the design for our guidelines, reduce, make a product redundant by abandoning its function, by using radically different tools. Rethink, reduce, reuse, repair, reproduce. There are almost 10 R's are there. So these 10 R attributes are considered in this paper. So these attributes will help the designer to design the sustainable products, which becomes. And probably this is one of the very good attributes I found from the Matthew Atkins. He published the paper in 2018, the intergeneration. So this is a chair which we think this become a social attribute. The same chair is used by all three generations. It is using the and the young people are doing yoga and grandparents kids on the chair. So this is intergeneration. This is one of the attribute when you are considering the social design for the product, not social design for the product design. When you are considering the social attribute, so like that there are a lot of things are done in the social dimensions of the product design. That there are a lot of research from the MRI scanning, how the MRI scanning becomes social. Those things are mentioned. And regarding the social, there are a lot of attributes we have developed, what are attributes we have the beginning designers, product social sustainability, considering this all we have mentioned here. And then, so this is the methodology we have analyzed to make the product system start listing pillars. And we want to develop the indicators. Now, when the design is completed, we should know whether the design is sustainable or not. And how do you know we are the quantifying the design by these the terminology called this STAI indicator. So that indicator will tell you that the design product is sustainable and how far better is from the old product. Like that. So in this study we discussed about 5 PMs and SPMs, and total we are able to give 131 guidelines for the environmental aspects of it. And for for social, we are able to do 32 guidelines for the medical designers when they started designing. So in total, we are giving 163 guidelines for the medical designers when he is considering the product design and the conceptual stage. So these experience in designer in creating sustainable products. So quantifying them is essential for highlighting the sustainability indicators. So what we are proposing is we are developing for the future for as sustainable design aspect indicator methodology. So this indicator this will give us a score in the product, the existing product, or maybe redesign product, or maybe alternative of the product, maybe to the alternative concepts of the product, or product level design. So this will give us the indicator that when you go through this methodology, you come to know what is score out of 10 for this product mentioned in this system. That is what we have. So, this is any question.
Thank you so much, sir. It was quite a detailed presentation. Thank you once again. Next, I would like to call upon Ms. Vrunda GS. A big round of applause to Ms. Vrunda, please. Can we have ma'am's presentation?
Good afternoon, everyone. My presentation is on micro-level analysis of marigold flower waste. See, linking to sustainability, nowadays temple waste, what we are getting. So many temple waste we are getting from temples during festivals and other occasions. So how we are going to use that type of waste in an other affluent studies. So first thing is in introduction. See, I have done micro level analysis of marigold flower. So especially in the temple waste, different types of flowers we are going to use. But here, for my study, that I have chosen marigold flower, one thing. And then here, analysis, when it comes to analysis, I have done SEM analysis of scanning electron microscope, X-ray diffraction, XRD, and then energy dispersive X-ray analysis, that is EDX. So here, these analysis, we will come to know what is the morphology of that particular temple waste what I have chosen, and also what are all the elements which is present in that one, and also how much percentage it is present. And here I am relating this work to the paint industry effluent. Whatever the effluent we are getting from the paint industries, it will be of whatever the color, that I have chosen white color paint because other colors, what we will do is with that white paint we are going to mix to make that colors, make that particular paint into different colors. So how it is related is I am using this marigold flower, a setup, column leaching setup. That marigold flower I used to pass that basic paint industry effect. So this analysis what it has done. So before whatever the morphology or whatever the elemental composition which is present, after passing, so how that morphology, elemental composition will get changed. So these are all the literature, especially on marigold flower temple waste. So much research work it is not done. That is a research gap we can tell. So whatever the material that I have chosen for the analysis, in the future scope, the future that material is going to be used to remediate the paint industry effluent. So this is the basic work that I have done, and very few works it is previously it is done. They have evaluated the use of flower waste as a byproduct for the treatment of contaminated water. So contaminated water, byproduct, the flower waste which is used as a byproduct for the treatment of contaminated water, and also characterization of marigold flower. The technical scientific name is Agates erecta, and here they have done an analysis. So how the structural as well as morphological analysis. And then here, effect of sewage sludge on marigold flower. The same marigold flower it is chosen and how it is affecting on the sewage sludge. And see, these are all the technology that is used: SEM analysis, XRD, and then edX. So one by one, what is the methodology that I have used in my study is collection. So the sample, the temple-based marigold flowers is collected from the nearby temples, and then it is drying. The process that is the marigold flower, whatever it is collected, it is dried. Yes, in to room temperature, and even the oven is also used to dry it fast, and it is set it to a normal, that is room temperature itself, and then grinding, that is crushing those into a fine powder, and that grinded or powdered sample which is used for the SEM analysis at edX and then XRD. So these are all the scanning electron microscope. So through SEM analysis, what we got? The first thing you can observe 100 micron when it is through the 100 micrometer when it is gone through and scanning electron microscope. That is the morphology or texture what we are going to observe in the first one. And second is a 15 micrometer and 20, then 10 and then 5. Means in that in detail study that has been done. So you can observe in the pictures. So more of a texture is there. It's not a rough texture, and what is the arrangement? It is parallel, and this is the selected area and edX energy dispersive X-ray analysis it is done. You can observe here potassium, phosphorus, calcium, again potassium. Means the potassium content is more in this marigold flower. And here the elemental composition with respect to this. So carbon 55.98% is there, nitrogen 3.12, oxygen 37.35, phosphorus 0.36, potassium 2.94, and then calcium 0.25. See, these are all the elements of what we found out in the edX, that is elemental composition. Actually, this is very helpful in absorbing the things. So carbon, you can just check in the charcoal also, it absorbs more. Carbon content is more in that. So these are all the contents that we can adopt, and what I am planning is the paint industry effluent, whatever it is collected, I making column bleaching is one column setup. In that, I am going to fill the marigold flower powder what is prepared. So these are all the micro level analysis that it is done. So before that, the paint industry will be tested. That is ICP, inductive coupled plasma mass spectroscopy. There I get all the heavy metals which is present, like nickel, chromium, cadmium, zinc. These are all the heavy metals. If you allow these heavy metals to the environment without treating, then it will
But this basic principle even can be applied to Indian statistics also. But here they have used something called induction heating. So as we all know, we have induction cooker, induction stove, everything. The basic principle is the electromagnetic field. That also we are concerned. And in the electromagnetic field, if we just take it as induction method, we have all electromagnetic radiations. But if we just look at it in the microwave, we have only in the electromagnetic like full broadband. I've chosen only microwave to do the heating. That's the only two difference between both of them. But here in induction heating, what they do is you can see the circuit over there. There is a coil which is going to promote the like electromagnetic field. If that field is being kept in near to the road, maybe around some 40 mm to 50 mm gap if I'm giving, and that electromagnetic radiation is going to cover and heat up the bitumen. Generally, heating we want it to be uniform, and bitumen is not going to get heated up within 1 or 2 seconds. I'll just pass like an iron box. I cannot expect it to get melted. It requires a small ingredient which will promote the heating. For that, the best concept they have introduced in this topic is they have used steel fibers. But there was an objection being raised on this topic telling that steel fibers will create wear and tear of the tires of the vehicles when we move on it. Automatically, the tire quality may come down. So this topic was not that as it is being accepted. They had some many limitations also. So, but this technology or concept was being uplifted. That is for sure for further studies. So if I just like previously have told there was some like statistics I gave on bond and NHM. If you just look at it, the cost analysis, as per that budget it is 272,241 CR. So that 5% is 12,000 to 14,000 crores annually. And typical lifespan of the road is without any maintenance, at least it should be in working condition for 15 years as per the design and not about execution. So with proper maintenance, I can push it up to 7 to 10 years without any pothole filling kind of thing will not go, only the surface treatment. Then we can extend the lifespan to 20 years. But that means that self-healing of roads by induction heating, in a paper they have mentioned that we can do this process of heating the bitumen and filling the cracks and rejuvenating the road for its actual, like at least 80 to 90% we can expect it to perform original. That will be 3 times in the lifespan of the bituminous road we can do. That means in 20 years I can go for 3 iterations of passing that induction coil on the road so that in the micro crack level itself, if we do that, we can extend its lifespan to 3 times. That is the observation they have made, and as I told, we need it very badly for India also. So the total cost of the repairs here, if I just take the lower number of repair maintenance, 12,000 CR into 3, we have a budget of 36,000 CR being saved to our government. Hardly we can spend for that induction heating, the high intensity voltage like on the setup where it is supposed to do the induction heating. It is not even being matched with that 36,000 CR. Hardly a very small 0.5 to 0.6% budget of that can be used for the system. So, in the earlier studies here in this diagram, whatever we have used is steel fibers, they told. But India is very good in doing sustainable tasks. Keeping that in mind, I have priority for steel scraps. I cannot call it as scrap because, as we all know, steel is the material which can get recycled at 100%. The only material on earth which doesn't have much residue. Up to 100%, if I am able to recycle, I can recycle it. But reuse is the task. We have in India hardly 25% of the recycled steel is used efficiently. But when we look at it with the road stretch or highways, entirely in India, we have a very huge length being spread across the country. So if I just being accountable for the huge amount of asphalt being poured on the road, if we are able to use the steel scrap, the 25% may jump to 50% possibility is there for the reuse for a betterment of the roads. So I have chosen steel scraps, like my students have collected from some nearby milling unit where after milling some powder will come in a spiral shape that we have brought it, and to chop them into aspect ratio of, and just about the aspect ratio. Aspect ratio 5 to 10, they have made a range, they have chosen 2 types. Because we cannot 100% be specific on the scrapping characteristic there. So they have categorized that into type 1 and 2 and they have mixed it later. So this aspect ratio was just typically being taken as a comparator to steel scrap, steel fiber. So when I just look at into the key studies previously whatever been done, we can observe that all of these are maximum being done on European countries. And hardly I have only one person who has explored in 2022. I can provide us an overview of the microwave method, not the induction method. So we want induction method to be more feasible than microwave method because microwave method need a closed environment to address the crack. That means we have to cover the crack just like boiling a vessel or like that. But induction heating is just like ironing with an iron rod. So that seems to be better compared to this would be my research gap. That is induction method and usage of steel scrap in place of steel fiber. Contribution of the paper, how maximum we can go for recycling steel being used for the road vehicles. The objectives just now have already put across in my explanation. We need to achieve a self-healing of cracks and bituminous pavements using steel scraps, and there should be a mechanism which is being based on induction energy, and it should be an economic path of repair and rehabilitation. Obviously, being Indians, we should have the economy in mind for the huge population we address. So we have to take care of economy. For that, this would be the better one. Concentrating on the topmost layer with rich steel scrap ratio of effective results. This point I had added recently because the proportion what I have chosen is 10, 20, 30, 40% of steel scrap being added, not replaced, added for bituminous carbons. But the
we are getting 5. Okay, that is going to be taken low. Compared to other results, you can just see 5% is the 5 yes. 5 is the optimum vital content we have obtained. And those values I have plotted here. Everywhere we can see the percentage vitamin content 5%, we have the lowest air, like approximate average air words. And if you just look at the bulk density, maximum is 5%. Here also, we can choose 5% as crucial because we want to match all the property percentage of optimization. So 5% seems to be the better one. So optimum vital content by this experiment we got is 5%. And next what we have done is ultrasonic pulse velocity test. This is very common in nowadays to do the non-destructive testing physically without disturbing the sample. If on road already an existing road is there, I want to scoop it out and do some testing things. The real nature of the road may get disturbed. So if I'm able to do the test on the road itself by carrying my instrument, fix it up over there, just like the stethoscope of doctors. If you just put the transducers, you can see there the mechanism. One transmitting transducer and one receiving transducer is there. If I'm able to do it, it may be on either side. UVB have 3 methodology. This is the tar road. I can put it on top and bottom transducers. One transducer will transmit the waves, another will receive. Or else on the same place also, some inaccessible points are that we can do that. This might be that way. So since we have the Marshall modes available with us, which are portable in hand, so we have tested them using that methodology, and we have breaking them using Marshall stability. In the process of Marshall stability test, we get break up into 2 pieces that you can see in the second one. This is after healing through induction, the third diagram. I have not simply sticked it or kept it together. I have matched the pattern of cracking pattern, like just matched it. Just like if we cut the biscuit into 2, we are able to join it through that biscuit. So same way I did it and kept it in induction healing. We had prepared one small methodology. So we have actually students have used induction stove. They got into college and they have kept one electromagnetic field to create. They want one aluminum plate. They bought one aluminum vessel. They kept it above and below induction, and in between they prepared one slab, one small 20 thick slab. They are able to create that circuit, and they have shown the demo also in TechNotes or they won the prize also. So based on that mechanism, the heat that they are going to get after healing, this is a pattern. That is, one at if I let another will come together. That clearly indicates that there is a flow of vitamin through one to another by melting of that through steel fibers. So this is the mechanism they have used it. And in ultrasonic pulse velocity test, as I told, the percentage of steel fibers, I have mentioned it as fiber, it is not fiber, it is scrap. 10, 20, 30, 40% been added to the bituminous dose. So before cracking, we are expecting the actual pattern or molecular structure of the bitumen. We got 16.5 is the ultrasonic pulse velocity number we got it. We have different units for that. We get the values in speed, we get the values in velocity. In microsecond, different parameters are there. But I have consolidated that into a single digit, that is 16.5, 17.7, 21.5. That is before we crack the sample. As soon as we crack, we can see that there is an increase in the value of ultrasonic pulse velocity. That means the time taken by the material has got increased. It has taken 18.4 in place of 16.5. That means the travel time of the waves from one transducer to another from 16.5 has jumped to 18.4, indicating there is a air gap or the breakage or space has been created because of cracking. So again, if I heal it, it will move back to 17.3. Clearly indicates it has shown its connection. So the continuity of the matter like continuum has happened so that the waves have been propagated efficiently. So we have got 17.3 after healing. So the rate of healing we have converted it. We are getting 57.79 from 10. 64.49 from 20 and 30 is 82.14. But if you just replace the steel straps beyond optimum level, automatically the efficiency comes down at one point. So we can observe that in our 40% replacement, it has dropped down to 80. So we have chosen 30% steel strap as the efficient one to get 82.14% optimum performance. That is rate of circuit. So in my work, I just want to conclude only 2 points. One is optimum vital content, 5% we can stick on as per Marshall stability test, my results. And UPV test, we have 30% replacement can get 82.14% of rate of self-healing we can expect. So it's a very simple study, but in magnification, if you go on depth with results, I expect this to be done in India. I wish my India to have a road without pothole. Keeping that in contact from my B students level, I'm able to get these findings. So these are the limitations actually, even we have to look at into the limitations also. There might be some really huge gap why we are lagging in it. The high initial investment automatically, even though steel is part of scrap, it is not scrap. We want to spend some money for that also. We have right now this year 23 to 28 rupees per kg. Seems to be simple, but actually in terms of road quantity, it is huge. So induction heating and heating setup for roads. For that, we need somebody from mechanical or like any other departments which are going to prepare us that circuit or model. Like in civil engineers, we have our own limitations. Beyond which we need some other departments also to fix it so that we have that entire setup which moves on the road and get us. We might have done a demo on induction stove, but that mechanism has to be converted to a machine on the road. That needs to be done. That is induction heating and heating setup for roads. I'm not saying that it is not there. I have seen one a pilot study from the same person, Eric Schwarzman. He has done it for European country for a 20-kilometer stretch. He has done the heating also, and he got patented also for European countries on location. So I just want that to be cost effective. How industrial heating can be done on a regular road. Steel scrap uniformity, we cannot expect the sources are different. So automatically we need to think of the characterization of steel scraps. And energy consumption on road, if you want to do high volt of like electrical supply should be there to generate the electromagnetic radiations over there, that needs to be a concern. And depth limitation. So how much deep we want those induction means electromagnetic waves has to transfer. Are we really concentrating on all layers of road? Are we restricting it to the specific layer that has to be the limitation? Yet to explore. And performance durability, since it's a very short term work we have done. So we need it to be an extended study. We don't know like after 10 years what might be that induction heated road will be in what condition has to be explored that is needed. And heating efficiency, how efficient we can heat the road so that without getting trouble with the basic properties of materials, without compromising the quality of the materials. Future studies we need to explore different percentages of these steel scraps on asphalt roads, which 10 to 40 is not enough. We need to even go for after 10 might be 12, 14. Like, we have to just optimize it further, might also be the concern. And there is, I heard about an instrument called heating crack simulator. I heard it or like somewhere I have seen in the literature. If my work will pass through this crack simulator studies by casting the 1 meter by 1 meter slab, if we are able to pass through that crack simulator, after healing, before healing, we may take not only UPV and Marshall study tests, other tests can also assess the significance of this. My concern because I don't know where it exactly that instrument is there I need to go through. So if that is a case, we can even explore that also. So these are my references. You can see up to 2024, just previous 1 year also, people are behind this topic. Like they have gone for induction microwave comparison, but in all European countries. They have a restriction. Today morning I was searching on Indian map on how to temperature in different locations have a contour mapping, like color mapping will be there, red color, very high temperature. That I tried to add on my slides, but I couldn't get the genuine data, so I just kept it. Meteorological survey of India, I just checked. I need a specific data so that we can even map and patch also. Like these are the locations where we need not to do induction heating. Just the temperature of that during summer will melt the bitumen and pour the heal, cracks and heal it. But for that, we need to add the steel scrap for sure. If steel scraps are there in high temperature zones, even by itself it can heal it. But in locations where temperature is a concern, we can make the induction healing. Both. For India, we need both. So some of the studies are out here. Over to the questions, please.
Thank you, ma'am. For the question answer, we'll have a panel discussion with the question answer.
Thank you everyone for this opportunity. I'm very grateful to AIDC team. They are very organized, very frank. Even with the bag, what they have given, the thing what they have printed, the way they have communicated us, everything is very systematic and we are inspired. We AIDNs, we will follow Acharya's road.
Thank you so much. For a panel discussion, I would like to call upon the HOD of Fashion and Apparel Design, Ms. Ashwini Joshi. I would like to call Ms. Niveda Chandrasekharan. Also, Mr. Baswaraj Sankor. You can kindly take your places up. And Dr. Soumya T. And Ms. Brunda James. All the five of you all can join us for the panel discussion.
Hello. Good afternoon, everyone. I welcome all the panel members for the today's discussion. So, from the morning, we are going through all the sustainable practices, their benefits, advantages, disadvantages, and all. So, basically, we have covered some topics like recycling, upcycling, and natural dyes, eco-print, thin technology. So, several topics we have covered. So, here I just can see to that all of our motto is the same. It is just to take care of our ecosystem and take care of our motherland for upcoming generations. So I just would like to listen from your end. Now all the researchers they are putting their papers where some small sampling they have done, maybe some prototypes they have created. But how far it is benefited if it is not getting commercialized? Like it has to come to the overall market and the customers they need to enjoy it, they need to use it. So I just want to know how it is important the things should come to the commercial market. Unless it comes to the market, like it is not going to benefit anybody. So maybe whatever the things we are doing here, in the soft or the hard copy, somewhere it will be like hidden. Like people will not get to know about it. So it has to come to the market, how important it is for the private or the government sectors or even the industries also, how they can play a very important role in bringing all these research papers to the market.
So, thank you for this question because the sustainability business model, which even I work in industry. So, when we design sustainable products, we lack the business model. So it's becoming very challenging for these days because only the tag of sustainability, the research says that there are research that it is going to sell more, but the tag of sustainability and the lack of the business model to sell it to the market, commercialize the market, it's a big challenge for us in the industry. So having said that, anything to make it model workable, the business model workable, the government regulations, the government should take action. If you go to European market or US market, unless and until the sustainability, the carbon footprint is put on the product, not allowed. So these rules are coming up there.
other concepts. Like from them, the idea which they have been explored in their career can just be a mark. They just do the presentation. We have many activities we have like idea patent and some idea box. Many things are there, but they just get stop there itself. After their presentation in the final year, they got some marks and they're done with it. So if at all any efficient four or five such kind of ideas, if they are being actually the colleges who sponsor the students show their motivation to convert them into a product, college 100% have a separate idea cell. If we need them, they 100% make that conversion to happen. In that level itself, if you are able to make some implementation of the products, some trial products, even to our college only, we have huge population of students, they have their own family, and even the housekeeping. So take any class on a population, we have huge number in organizations. For them itself, when very small like sample of that product is being introduced as a product in hand or some technology in their mobile app or anything within the community of college itself, if we are able to launch it just like a trial period. So from there automatically it will show its magnification. Example I have seen in Ganesh Utsava every year they host it in Vasalpudi. When we came out of that activity, this MTR people have invented three sambar powder different flavors and they have made it just for 10 rupees packet, but it was not shown as 10 rupees there. One small, very small packet. Just a token of publicity, they have given that powder to every audience over there, just after going out. This is marketing technology. So after going 100%, somebody, like especially women, they keep an eye on that sambar powder and they get to know about it. So marketing is all about where we want to focus the population for what kind of topics. If it is a topic which is really want to be big scale, like if you want to address some electrical waste products like Vigo, approach was make a collaboration with the students. If the students' idea get cleared over there as a product, then they may accept it. Or that publicity can be done. So through college only we need to do, as per my words, we should take the first initiative and publicity marketing thing. In small dose it happens automatically, magnifically it will go. And we have seen many like industry expertise will come to the college in very different iterations and they also do say, come up with your idea, we are there to help you out in preparing the product and marketing. So such opportunities should be used by our college team that would be my concern.
So I agree with you. Like if all the stakeholders take the responsibility, definitely the things can come better on the real market. Yes. And one more thing I want to highlight. Today morning I heard with Sushant's talk. Like he was talking in detail about the bamboo craft and all. So even today I also had imagination that bamboo is built only for the craft thing, make all this, that, this thing and all. But today I got to know that it is not only that. There is so many things in that. So I feel that it is not only the bamboo craft, we have n number of clusters in India, but we are not aware about it. Even our students also. So I feel that somewhere we need to make it very much mandatory that they do at least 1 month of internship, otherwise we conduct some workshops for them so that the awareness will be created in students and further they will take it. Because it may create further employment and they help many people directly or indirectly. So I feel that like each and every domain should take this as a serious thing.
Hello, this question is for you. I was watching your paper regarding optimum retail. As you say that the materials has to be heated till 55 degrees Celsius to match that viscosity during the process of heating. But can't these have a side effect of overheating and releasing extra energy and change, bring a lot of distraction and climate change?
55 degrees is the softening temperature of bitumen. So like if I want bitumen viscosity to be dropped so that we can fill the micropores. So we will first do the calculation, we get the softening point as well. Actually it is 55 to 130 degrees there. I have chosen the minimum value because higher the temperature automatically as you go. Climate also will have its like addition or if some locations 54 degree we have in India many locations also. So that is not applicable for all regions. 55 degrees for any material to get heated up it may have cumulative effect on weather conditions also. Like if we can exclude it based on region. So we have mentioned like if we have Indian map with our weather diversity, so we can map for that this region needs this much of heating, this much of induction mapping is required. So that part of the work we need to do also.
During summer, we are lost towards hill stations.
So that's what I mentioned. In summer, we need not to do induction cold part, but if steel scraps are there inside, they take care of uniform heating of the entire like layer. One layer, what we are going to keep it. Just like that, if we heat only at the top surface, the bitumen gets created. I want it to be uniform throughout that thickness, some 40 mm, 50 mm as per the grade. So to achieve that, we are giving steel scrap, but induction method is optional for locations which have already 50 or 55 degree temperature. We can accept that also.
And what when you're doing with mass productions, how do you control radiation?
How do we control?
Radiation, so you're using a different process of heating, microwave and induction process.
So in induction, what already existing methodology is there when I go through that, what they have done is this bitumen layer laying machine is there, so like roller machine. So the location where bitumen actually flattens the machine which flattens the bitumen, there they have installed two coils which are 50 mm gap from the top surface of the bitumen. That technology they have already implemented. They have two running coils which will generate electromagnetic field. And they have already, like in the machine itself, they are using that machine which will lay the bitumen and flatten it, roll it. The same machine they have installed the induction technology also. So just like an ironing without having a contact, they have the machinery. So that they have done it for asphalt in other countries. But I don't know, like in India, how we need to take it out. That's why we spoke about machinery part of thing. We need a lot of study. And we need to collaborate with other mechanical or electrical domains to come up with a solution for that task.
My question, Mr. Baswara, I think I really enjoyed your presentation. The thing is that on sustainability, like we have for humans, we have a parameters to check, like a carbon footprint and all that things. So you have been talking about SPDM and all metrics and the detailed study which you have done. Are you thinking to have that metric system, a digital metric system available with the product where we can see how we can make it a sustainable and having what life is left, like a battery or whatever you like to have. So is it some your work is very detailed and very important. Can we be able to take it with all the product and get the reality check of the sustainability of this products?
Sure, sir. I mean, currently, there are a lot of commercial software. For example, Singapore, Lami, Ecoinwin, OpenStream. There are softwares available. These softwares will tell you if the data is available. If the data is available, and will be taken because getting the data is a huge task. Because you have the suppliers all over the world, all your products, and getting the data from there is a huge task. And doing that, getting the data and getting the software and give you the result on this much emission is global warming index systems. The impact categories we say into the softwares. The impact categories are ozone layer emission, carbon footprint, global warming index, there are a lot of impact categories. Against these impact categories, how much this product is contributing to the sustainability, those indicators we get. But this is done when your product is ready. A product is into the operation phase. A product is into the use phase. So, I mean, then only you will get the data. And then you can run this using this software or the analysis and you will get the data. But the study should be there before this. I mean, somewhere when you are starting thinking about the product, that time, if these indexes or these matrices are available, then it is easy for a designer to come into these. You can see it as a avoidance instead of wasting and labeling. You can avoid these better designs. So these matrices or indexes will be critical. So what is your
like my question that this is, can I use this knowledge in my curriculum when we are doing this thing like product design or any other thing? Use this as part of the curriculum as one of the subjects that we will become much more sustainable thinking.
Definitely. So we definitely can use this because these should help the designers. The intention is that only. And if it is coming to that action, definitely will be very useful for us also. And I hope I do not see the curriculum of Acharya, but definitely there should be kind of a sustainable design which was
Basically, I want to talk about the fast fashion and the slow fashion. So fast fashion is the one where you are not worried about the quality of the product. So within short time, you want to produce more and you want to sell more. So obviously, the cost will be very less. Maybe for 100 rupees also you get a shirt. Okay, but soon after 3-4 washes, that will go as a waste. But whereas the slow fashion, you take every process very carefully. So obviously, the labor is more and the cost is more, but there's no compromise in the quality. So we just can make the student that instead of going for the fast fashion where they buy for 1,000 rupees 4 shirts, if they go for one shirt of 1,000 rupees, quality is assured and they can wear it for the longer time. So we just can bring them from out of them to sustainable practice.
Thank you so much. A big round of applause for all our panel members. Thank you so much for joining us here. You can go ahead and have your seats. There was an impeccable decision that took place, quite interactive, and thank you. Once again, I would like to thank all the panelists once again, I would like to thank all the panelists that were here. Before we proceed for lunch and end our first session, I would like to thank each and every presenter who was here. All your hard work, all your efforts were well seen. And also, after we wind up with lunch, I request everyone to come back and be a part with us with the second session, because after the second session we are going to have the distribution of certificates, the distribution of the participation certificate. So requesting everyone to not leave but stay and join us for the second session. And also to close this conference, today is the last day and we wind up with this entire 3-day conference that we have. To close the conference, we have the fashion and apparel design department coming up with a fashion show, so that we can close this conference with a bang. So requesting everyone to kindly stay back and join us for the second half. Also, for the authors and the co-authors, the lunch is set up at the central library area. For the students and the faculty members, it's set up in the mechanical block. Thank you very much. I hope to see you all after the lunch session. Thank you.
well informed now. So the professional competencies of Indian people check it out the ERP architects registration board in the UK, or you can come to ACA, which is the Australian Council of Architecture, or you can visit ExitLab, which is the Register Board of Architects, or you can go to NCARP, which is the American board, where they all have professional competencies before any person is given a license. These competencies are embedded into the architectural education. We do professional practice, but it is, I must say that very practically the professional practice is not sound enough to prepare ourselves to be professional and face the world beyond the school of architecture. So the professional competencies that need to be embedded into the curriculum, we have to develop the technical proficiencies that includes mastering design tools, technology, and methodologies. We need to develop critical thinking, which helps us analyze and evaluate skills of sound decision. Creative problem solving, which involves innovation in solving design challenges. Ethical practice, which is commitment to integrity and accountability. Remember that architect as a leader of a team of developing a project is needs to be committed to be very responsible. Communication skills, clarity, visual, verbal, and written expression. We are all good at it. I heard a couple of speakers talking about it. I think India has picked up great commitment towards this communication skills, and we have been doing not just in India but globally, absolutely in a great manner. And then the next one is the collaborative skills, effective teamwork across the skills. We all have to work as a collaborator, as a partner team now, which means that we need to develop the ability to collaborate. And we also need to develop cultural sensitivity, respect and engagement in this context. And last but not the least is sustainability. Our design should be rooted in environmental and socially responsible mentality. The Council of Architecture, which the document which we see, it campaigns these competencies to create resilient, relevant, forward-looking curriculum. And if you look at what a great friend Patrick Schumacher, what he says is that architecture education never is something back 50 years back. It's very relevant today. He says architecture education is in crisis. That's from a profession, which is very true. And that's one of the reasons that we hardly get employed who come out of college. And our salaries are very low, and our profession is not very business. The reason is that the school of architecture don't prepare us to the profession and the practical professional life, which is outside the school. The reason is that most of us have a problem of development. Most of us have a big gap between practice and theory. We need to address these challenges. These are systemic challenges, and we need to address these challenges. For example, first one I would like to say is that among several security challenges, which actually hinder me from performing, is the rigid curriculum. Our curriculum have become very rigid, outdated, and flexible frameworks. And for that, we need to encourage modular, evolving curriculum, responsive, industry, and social skills, which is not happening because we try to revise our curriculum every 5 years and we don't realize that things change so fast. And we need to keep a very vibrant curriculum that moves along with the kind of development that is happening. And the next challenge we have is resources. Limited access to technology, it's a good factor. I faced this very small problem when a person from A who wanted to become a teacher in college, but she did not become a teacher. Unfortunately, she was a lady from another major city. And just because her master's of architecture was 18 months, and she got that particular master's, they had to recognize that she also about it's very unfortunate. So we need to see that people with expertise should be involved in our should be very not really in terms of degrees, whatever it is, besides everybody immediately is a very gives us a big flexibility, and that helps us in the future. As long as the states start implementing that policy, we will still have those challenges to keep them moving forward. The next one is faculty preparedness, insufficient training in new pedagogies. So we do have training sessions which happen around, but that is not sufficient. We need to be prepared with the contemporary development that is happening around and prepare our faculty or teachers to impart the right kind of education. For that, we need to establish continuous professional development workshops and possibly doing exchanges and research. We are doing quite well in our research in India because India seems to be the highest paper producer in the world. Paper, journal, peer-reviewed research in the world. But still, our degrees are not yet recognized. Cultural and regional diversity. One size fits all curriculum fails to address India's pluralistic society realities. So this is something that we do have the curriculum generally different from different regions. But if you look at the overall structure, it remains the same, which is because of the fact that we don't have the laid down by the president. This is how we prepare things to become much more severe and more standardized. These kinds of regional diversity should not take into consideration. Regulatory limitations is another big issue. Mismatch between evolving limits and application standards. Industry discovery gaps between academia and real world practice, for which I suggest that integrate live projects, internships, we do have internships, how the students get paid. I was told, and many of my students they don't get paid. And we also something like that they have this demand from the students or people who actually want to work there. We don't know what is the reality. So these are some of these which came up in social media and people have been talking about. We also need to look at mentorship models. And before I would conclude this whole challenges issue, I would like to talk about student preparedness. weak foundations in critical thinking and creativity. That's a big challenge, which means our foundational programs should be very strong. Unfortunately, our foundational programs are based on the system which was the system and the philosophy which was based on 1990 Holocaust. Unfortunately, for 100 years we went forward with that. We need to change. We need to intervene very early and create curiosity and we have enormous resources within our country to apply that. And finally, this is the most important part, is technical integration, infrastructure and affordable issues. So this is another big issue because many of those institutions do not have the right functioning infrastructure to actually introduce technologies that are the most required. So we need to see what are the options we have and how we can prepare our future architects in one place so that they are technologically, so embedded into the education process. And I see, I've been to many universities in India, and I found that actually some of the drawings prepared are absolutely stunning. But they are highly capable ones, and they can do a lot of work. But there's some sort of disconnect that is happening between what is in practice and what is happening. It's not just about presenting beautiful drawings and making nice perspectives and the 3D image or whatever it is. It's much more beyond that. It has many more components which we hardly try to learn in our schools. So what do we do to develop a highly robust education in the system? To address challenges, we need to build strategies. So we need to first of all build strategy partnership with firms and institutions to foster internships, research and real-world exposure. This is a very important aspect because the schools should sort of network with the practices. I know this is happening at some level in many of the schools, but they should happen in a more formal way. There must be a constant interaction between the practices and the institutions where there is a cross culture of practice and academia. And I'm not sure if many schools have this, but some of the schools might be having this is about the industry of housing course. So we need to see that every school has an industry advising board, which is people from practice, not just the data, the engineers, the builders, the developers, the contracting companies who actually know what they want because they are have your curriculum aligned with the emerging trends, especially in this big one coming and rising on board. We need to develop collaborative projects, arrange guest lectures and workshops, which is happening, as I see this conference in one big aspect to it. Structured internship to ensure meaningful experiential learning. So the internship is not just for 6 months. If you look at the LSA model, London School of Architecture, you can go to London School of Architecture and see how the apprenticeship-based learning has become highly successful. So that particular school actually sort of implements more than 150 practices. So each of these practices have some sort of a connection with this school in some way, whether in real time projects or maybe they will appoint this school as an intern. So that the learning as well as experience is happening there. So industry sponsored competitions, I think it happens all over the world, but we don't really know what is the outcome of it. Sometimes it's good, sometimes people are benefited out of that. Like when I was studying architecture, we never had that industry exposure.
But NASA was a big exposure for us. I myself won the American Award twice in 88 and 82. And that prize, NASA prize, the American trophy, became a source, became so helpful for me to get international scholarships in my master's degree at the time. And I'm sure the NASA's have really been big and is highly resourceful. And this student body, which is supposed to be the largest in the world, should become one of the major stakeholders in the development of our country education. That is why I said there must be a strong student body representing the council of our country. And that should be regional as well, so that the student voices are heard with the council and they know where research collaborations generate knowledge and many aspects in terms of sustainable design, material, actually, strategy, and technology training, not just for the students, but also for the tutors, faculty. And for example, there is a big thing now, building information modeling. Somebody was talking about AR, and AR is a big thing along with robotics and advanced digital software. All these things need to be and easily accessible and experimental. Basically, the student should be in a position to actually, experience and work through their projects. More than anything else, I think the system which is very important for two-way conversation is the feedback mechanisms. And these feedback mechanisms, which should come from the students as well as from the teachers, is so much important because that creates the mutual trust and mutual engagement of hope in the road towards achieving academic excellence. So feedback, if you're looking at
Excuse me, sir.
yes,
Sorry for interrupting. Sir, are you changing the slide or staying slide?
still me, I know when to take the slide and do it.
Sorry, sir.
Are you unhappy to see Schumacher?
No, sir, I thought our system was having.
I can't wait to move the slides to the
Sorry,
I
sir.
don't have many slides, I don't need to show slides, PowerPoint is an updated one. You have to listen to what it was. If you want, I can pass on my keynote which you can distribute among the teachers at some later date. I might publish this in. So for your request, I will push the slide. So what Schumacher says here is current educational model is makes sense for the 1980s, which means this article came in the 20s, so it means we are almost 50 years behind. I'm not talking about technology, we have achieved certain amount of technology, but we haven't achieved the whole process of understanding how the education has to proceed and to real understanding of architecture. So we're still in the 80s. So, just to tell you that these strategies will not really stay active and practice.
Hello, Ted. Good afternoon, everyone. I'm hoping everyone has had a restorative lunch and are ready to dive in the second session of this day, of day 3. The last topic for presentation is design and agility. So moving on to the first presentation, we have Dr. Hemalata Dormani and her co-authors who are going to be presenting first. Can I have a big round of applause to Dr. Hemalata Dormani and her co-authors? Can we have their presentation, please?
In every knot stays a story, in every loop is a legacy. Pattern is just not a race, it's a memory made visible. So, good afternoon to everyone present here. Ambassador and Naidu, from the Department of Fashion and Apparel Technology, from the Kerala Technological University. I'm delighted to present my research titled From Threads Through the Threads, Pattern in the Modern Fashion. So you guys are really curious about what is static now. So this research basically focuses on the revival and the contemporary application of static, a delicate lace making technique with a rich heritage. So this pattern is not from India. It has its roots from the Egypt culture itself. So through this presentation, I would like to introduce about plaiting, its origin and evolution, terminologies and the global variations, and also the techniques, the designs which I developed for these presentations, and also the result and SWOT analysis with its future scope. So basically, tapping is an intricate lace making technique which is done using a shuttle, a crochet hook, or an eye hook, and a cotton mercerized thread. So this is a simple lace making technique which includes a series of knots, double knots, and also this art was invented with the evolution of the knotting technique. I hope you can see the tactic bar at the right side of the presentation. So when we get back to its evolution and its origin, we can see that Tannic is not just from its like Egypt culture, it has its roots even from our Indian culture, Chinese culture, and it is also like it has and it has also evolved during its whole transition period. So we can see if there are basically the medieval period, the ancient period, 16th and 17th century, 18th century, 19th and 20th century. So when it comes to the ancient period, we can see that the threads were the basic materials used to make the old clothes. So the thread even it was made with so finest threads that it has even influenced the Victorian culture. We can see one of the picture in which a woman is holding the largest shutter of that time, which was made from iron and even the shells of the sea shells, and it was also made with the bones of the humans. So through this map, I want to talk about the locations where the Titan has traveled. So it started with the Egypt, then traveled to Italy, Spain, Germany, Sweden, Finland, Turkey, and then all the parts of the world. But due to its time consumption and technical backgrounds, it is widely replicated. And it is also known by different names and different regions. Like in Italy, it is known as Ochi, but on the other hand, it is known as Violet. It is also known as the work of the shuttle or the work of the little boat due to the shape of the shuttles. And when we come forward to Turkey, it is Motown, where the shuttle has a hook at front. So what are the tatting techniques? Basically, we have three major tatting techniques. That is shuttle tatting, needle tatting, and hook tatting. Shuttle tatting includes the basic and the foremost shuttles, which have the head, the needle, and the card. But on the other hand, when it comes to needle tatting, it is the most basic and the most interesting technique, where a needle and a thread can make complete lace. But on the other hand, we have crochet tatting, which is a combination of both the tatting styles, where a crochet, a shuttle, a thread can make a difference. Like it can add a complete new look to your whole garments. As we all have seen the history and origin, previous to this modern jewelries, tatting was used for its stages. Like now, machineries have come up which has made the tatting like the most expensive kind of thing. But laces were related for 10 rupees, tatting takes 10 days to complete one complete lace that is of 6 meters to 7 meters. So these are few of the designs which I have developed. So these are the tatting kits which I have used to make the contemporary versions of this tatting. And here I have used is Malai thread, which is a combination of cotton and silk polyester yarns. And the shuttles which I have used here is made up of carry bags. So we can even think that we can use cotton carry bags, and also it is a part of sustainability as we can use old and old threads to make new designs. So let me take you to my designs. So this one is the motif which is gold, and it also named as teardrop because the shape of the motif depicts a teardrop, and it has a count of around 600 to 700 stitches per motif. The second one is the piece which is made with intricate square motif, and this is the most suitable design for formal wears and as well as casual wears. It can be like a neck piece, a cape, in even a additional lace technique for your designs. So this one is the heart motif, which is a mixture of emotions and also the technique of cutting. So this one is my take over the pattern, where we can combine 3 to 4 motifs of the pattern designs to create a new design. So this is basically known as a quadrilateral motif as it has 4 dimensions. Sorry. And we can also see that this can go to island design. And this is the most interesting part, which is the triangle motif. And this one design has around 700 to 800 stitches per motif, and the whole concept includes around 2000 stitches. And this is the most intricate technique which can be used for vibrant and colorful designs. The thread color and consistency can be changed with the variations in the shuttles. So this was the short research analysis which I prepared. So it was basically made on the visual appeal and complexity of the pattern. So the complexities of the pattern and the visual impact, we can see that design piece stands out as an emotional and also makes it decoratively appealing as it has a heart shape. And on the other hand, we have this design 5, which shows intricate tactic techniques and also makes it a modern and aesthetic edging apparel or cape. And at the first place, we have a teardrop motif, which is visually elegant and organic in shape. So when we talk about the second and fourth design, they are basically geometrical in shape, like the square and the quadrilateral. So it also says that we can have a minimalistic, yet we can have our heritage craft with us. So when we come to the SWOT analysis, we can see that tagging is making handcrafted, so it takes time, and it also needs to be durable. It's customizable, and also it is versatile in style. So that's the advantage of the tagging. But when we come to the strength, the weaknesses, it is time consuming, and we also have limited artisans who are working for this because it is high product it needs high production cost and time. So most of the consumers they put the alternative offers. That is why we are using one of our ancient craft. So if we all put our hands together, we can still revive it in our own styles. So what are the opportunities and how we can get it good? We can take the tagging technique to our niche markets. Like we can target the particular audiences, and also we can collaborate with designers who can make it more appealing. And we can also say that the machine made alternatives, the downfall of fast fashion can give us starting price for these arts. So what are the future scopes for this? So we can see that tagging is an immense scope in modern design. By using digital platforms and sustainable materials and collaborations with the designers, we can still make the global reach of this tagging. And the other hand, we can even take the initiative of educating the students about the stacking. As we all know, the tabling is like one of our ancient crafts. We can also see that India has the major tatting craft culture in the Andhra, where they practice tatting, knitting, and also the way we can use thread and needles to make products. So I hope we all can join our hands to make this tatting a craft which can be globally recognized. And at the end, I would like to thank everyone who have paid your attention and given me a chance to present my topic. And I would like to say that in the world which moves so fast, study can still remind us to slow down and also appreciate the beauty of each thought and book. I hope this presentation has unraveled not just the technique of tapping, but also the rich heritage and its culture. Let's continue to preserve and promote tapping, one knot at a time. Thank you.
Thank you so much. I would like to invite Ms. Shraddha Gandala for our next presentation. Can we please have a presentation?
Good afternoon all. I am Shraddha Gandala, 2025, and I am a graduate student from Accessory Design Department. Here I will be presenting a qualitative study on the design, sustainability and material. On behalf of my co-author, Mr. Vijendra Kumar and Mr. Jaydeep. So, as we all know, sustainable design is now a step in contemporary product development. And for designing a product, selecting the appropriate material is must. So, a large scale of phase and ecological harm caused by the conventional method that is take, make, and dispose, the industrial model. So, there should be a balance between the material, designability, and aesthetic for the environmental sustainability. So, this study investigates the potential of algae needs, the material made from the algae material for the biodegradable and sustainable material for ecological conscious designs. So, the objective of the study is to examine the algae needs as a creative, sustainable, and biodegradable design substitute. Examine how professional view and understands the product made from the algae, determining the implementation's real world problems such as cost, durability, and performance. Assessing how well materials made from algae are tied to the circular economy and sustainability trademarks. So here are the key studies for the literature review. First, the Brooklyn report laid the groundbreaking concept of the sustainable development, defining it as the development that meets the present needs without compromising the future generation. Further, the six are principles that reuse, recycle, recover, redesign, and remanufacture are known as the strategic pillars in designing a eco-conscious and a sustainable product. Further, moving toward a study from 2022 supports this research, identifying that algae-based beads as a renewable and biodegradable material with potential application in eco-conscious product design. Further, collectively, they gave the names to study the advocate shift towards the bio-based material and circular design approaches to reduce the environmental degradation. The research gave that we found was that existing research largely focuses on the technical properties and environmental benefits. Further, there is a lack of empirical and a data-driven insights into how design professional evaluates and respond to the novel materials made from the area. Most studies do not sufficiently explore the barriers to the adoption, such as cost, durability, usability, and adaptability. Further, the lack of real world user feedback and adoption trials. So the contribution of the paper, this study offers a comprehensive analysis of LDPs as a sustainable material based on a survey data collected from the 345 professionals across the various domains. It provides a quantitative insights on the awareness level, function concerns, and adoption intent. The paper highlights the real world challenges to the material adoption, such as durability, cost, effectiveness, and technical integrations. Further, it